Hello everyone. Lately I've been getting some of these FBT amplifiers in. Fred, Bert and Tony, I don't know what it stands for. The X-Lite-10A and the 15A, which is, this one's an 800 watt claimed, although it's nothing like that. And the 15 is a 1000 watt. I think the cabinet size is a difference, but I don't take the cabinets in, I just take the amplifiers in. But yeah, apparently, inadvertently, I ended up being the only person that I know of that's got the chips, the amplifier chip, the big power amp chip in here that sometimes blows up, the TDA8954TH. It's gone obsolete last year and there's no stock anywhere, although I've got stock. But you know, if you want some, I can sell you some. But I just thought I would show you this amplifiers because they're quite interesting actually. They've got a fiendish power supply. If I just turn her over so you can have a good look at the gubbins. Now bear in mind this is claimed to be an 800 watt device. Let's just zoom in a little bit on this so that you can see a bit better what we're talking about. I'm going to zoom in on the power section first, we'll talk about that. Alright, so on the power section, bear in mind this is supposed to be an 800 watt amplifier. The first thing you'll notice for that sort of power output, we've only got one switching transistor, that's that one there. So it's a single-ended power supply with quite a big transformer, and you can see the usual input filtering and the protection and the class Y capacitors to the chassis, and then various other little power supply chips to give the DC power supply for the power supply monitor, the PWM management chip, right? But the interesting thing, do you notice anything missing? This is the low voltage side underneath my hand here. Do you notice anything about this? 800 watt switch mode power supply, or claimed 800 watts, it's more like 200 probably. You know, this game they play with the RMS figures. But, do you notice anything missing? Have you got it yet? Yeah, there's no huge smoothing capacitors in this design. No circuits in the wild for this. I've been doing these for a while, but there's no circuits out there that I've been able to find which show you the schematic of this. So I had to work this out a while ago, and it turns out there's no large smoothing capacitors. Normally you have a bridge rectifier, then two great big sort of 2000 or 2500 400 volt capacitors to give a nice smooth decoupled DC regulated, not regulated but heavily smooth DC, into which the output from the rectifiers go to, you know, basically top it up in the UK at 100 hertz, because we're full wave rectification in the UK, onto the smoothers. But they aren't here, so they're the ones that sometimes when the voltage goes too high on the input, there's some of those capacitors that explode and make a horrible mess. But this hasn't got that, and they've utilised a very cheap offline power supply chip, and whoever designed this was really quite a fiendish power supply designer. Hats off. If I turn that light on, actually, you might be able to see a bit better, can you? Yeah, that sort of fills in some of the detail. But anyway, no big loud smoothing capacitors. So I think it's a 1 microfarad capacitor on the bridge rectifier. Yeah. So all you've got is that 1 microfarad instead of thousands of microfarads. All you've got is just this 1 microfarad, which is a fiendish design. I haven't seen or come across any other ones that do it like this way. Do it the way that this one does it, and it's there's quite a lot of ripple on the secondary side. You can see you've got the usual sort of size capacitors. You've got plus and minus DC voltage rails at 3,300 microfarads. Yeah, at 50 volts. So yeah, like 35, 40 volts, and two sets of smoothers, so you've got 6,000 microfarads on each side. But there's nothing at main smoothing frequency on this side. There's just this 1 microfarad across the bridge rectifier, and that feeds the primary of the transformer. The primary transformer then goes through to this single switching device, which is driven by a 20-cent chip, and these resistors here are all part of the snubber circuit. There's fairly heavy duty snubbing going on. You can see from the wattage of these resistors here. You don't normally have these on a switch mode power supply. So there's a lot of so there's quite a big transformer, 1 microfarad smoothing capacitor across the rectifier, and 1 transistor. And it's very cleverly designed so that it can vary the drive depending on the output side. So the output kind of overrides the actual ripple on the input. It's quite interesting, but nevertheless quite a clever design. No big smoothing capacitors required. But having said that, they do blow up. Don't know if you can see down in there. You see that shit stain down there? You can see. Can you see what's happened down there? We've had a major, the FET's gone, I expect. So they are a low cost design, but also they are prone to getting blown up. All right, so that's that side. So on that side of it, you can see what we got. A very fiendish power supply, very fiendish indeed. And then down this end, you've got the HF channel amplifier is there. The LF, I'll show another board, and this is the mixer input board, okay? But no circuits I've been able to find for these. So, yeah, I'm guessing people are repairing them. And here's one, this is a 15. This is the one that's purported to be 1,000 watts, not 800 watts. Essentially exactly the same design. This one's got a functioning single-ended switching. Normally for this sort of power you'd have either a push-pull or a quasi-resonant bridge, half bridge. But this has got neither. They've just stuck with a single one, and hats off to them to get that much power out of this without any smoothing capacitors. These chips have got very significant hum rejection, very high rejection of the actual hum on the power supply. So a little bit of hum over here is not necessarily a bad thing, because all the voltage of the mixers will all go through linear regulators anyway. So on the back you can see, I'll just take that off there, that's a clip I've put on temporarily for desoldering. And you can see there's the TDA8954TH amplifier chip, and this is capable single, if you bridge them, and the two amplifiers in there, so it's stereo, so if you bridge them together you can get 480 watts RMS into 8 ohms, which is quite significant, about 93% efficiency. So you know, you're going to get like 50 or 60 watts of heat out of this if you run it at that sort of power. Is that right? 93, 6 watts per 480. So it's going to be 25 watts. So you need a decent heatsink anyway. And these frequently blow up. I've been changing TDA chips for a long time, but now NXP, what used to be Philips, have obsoleted all these. They've all gone obsolete. You can't get them anymore. And you really can't. You just not. I have found a source for them actually. I've got this module here, which is uses the TDA 8954 chip in here, and I did a separate review on this. This is very cheap, and this is where, when all these chips, when Philips made these obsolete, did last time buy, in I think October 2020. A lot of Chinese companies bought all the chips and all the stock, and they went off and built this thing, which is supposed to be a 480 watt RMS amplifier. And yeah, I'll review this because it's quite interesting actually. Well, quite interesting, but yeah. So you can see from this that you need very few components on the output filtering side. And in the data sheet for this, I don't know what. Well, actually, I do know why they discontinued them, because I spoke to NXP rep. These chips were discontinued because they're just not clever enough. I thought, well, why not? And then you look in the you look in their latest range. They've got the same package. They're rated at much lower output powers, because I think they realised or recognised that they had some reliability issues with these. Even though we can have a look at the data sheet, but it's got thermal limiting and thermal foldback, but they still blow up. And the new chips, which are the same pinouts, are much lower. I think the highest wattage one they do is 125 watts, because they just don't need this sort of power. Because let's face it, this is not an 800 watt amplifier, or it's not even a 400 watt amplifier. It's claimed to be 1000, but there's no way you can get 1000 watts RMS out of a single-ended power supply with a transformer that size. Trust me, you can't. It's more like probably peak 200 watts, but they play this game with the specification, as you all know. And the replacements for these are all I2C controlled. So you, instead of using the programming pins, which this has got, you can switch into bridge mode and various other things, and the hold pin and shutdown pin. everything is done by an I2C interface. So they've taken this device and put a serial interface for control of this device, so you can interrogate the temperature and set the modes and everything else to suit presumably things like smart speakers and, you know, Bluetooth soundbars and things like that. But the interesting thing on this chip is that they claim that you can, even though it's Class D, and you can see it's got very small, if you look on this, you've got very small output filtering chokes, and there's a small capacitor network underneath as well. But you can see you can get away with very small chokes, and they say at medium volumes, medium powers, you can get very close to Class AB amplifier distortion performance. So they claim this is a very good fidelity for what it is. Remember, it's Class D, and most of the Class Ds are awful in terms of THD, harmonic distortion, but it's supposed to be quite good. So anyway, I've got to change this chip because this one has blown on this amplifier and the power supply has blown on the other one. But I thought you might find it interesting. We could actually just take that chip off, couldn't we? I'll show you how to remove the chip as a added bonus for listening to me rant for 10 minutes about virtually nothing at all. Right, okay. So I put the soldering iron on. All right, so that should keep us focused, locked in. Right, so what I've got around here is a couple of rounds of copper wire. You have to be careful when you're desoldering these. You can't really easily reuse them because I found they are sensitive to heat, these devices. It's one of the few things I found which seem to be quite sensitive. So I put a bit of flux on. And we could, the danger is when you use a hot air gun on these boards, they've been out in the field, the boards aren't dry unless you bake them in an oven first to get rid of the moisture that's ingressed into the PCB. You heat them, and can you see these vias here? These small plated through holes which connect the top and the bottom layers. I've ranted about vias before, haven't I? Yes, I have. I'm just a sad old man with a via fixation. But when you're heating this board up with the hot air gun instead of a soldering iron, you hear a pop or crack, and the steam in here expands and makes the board bulge up, and as it bulges it cracks these vias. So if you use a hot air gun on this board, you'll find that afterwards you're going to have to about check and put wires through some of the vias, and the worst thing is they crack in a speaker if you weaken them, or they go slightly higher resistance than they should be. They are very, very low quality boards they use in these amplifiers. Not fantastic at all. Now I'm chatting away here because I can't find my roll of solder. Where the hell's that gone? Hold on your horses one moment. And I just see on YouTube, The Sun, a UFO has been spotted hovering over the sea in Alaska. Yeah, I don't know if you noticed recently that the Pentagon has released a report on UFOs, and it hasn't really been noticed in this country. The people that I speak to that are normally interested in this sort of thing say, well, I haven't heard about that, you know. And I said, well, no, actually the Pentagon has acknowledged, they've released video of F-24s or whatever it is jets tracking UFOs with their infrared and their FLIR infrared and also their radar lock. And these things just, 20 miles away, they just zip off. They just zip off at incredible speeds. You know, if there's a human inside, the acceleration would splat them up against the bulkhead. No wings, no jet plume, no reactive propulsion system, and they exist. And they don't think they're Russian, they don't think they're Chinese, they don't have a clue what they are. And it just seems that everyone's just ignored that in this country. I can't understand why everyone's not going, bloody hell, what's all this about? Anyway, apparently the Pentagon has got some really good, classy photographs, close-up photographs of these craft with no wings. And they've buzzed missile bases in Alaska and pushed the missiles offline. I'm not a conspiracy theorist, and I certainly like to see evidence for anything I believe in, but it's been accepted by the Pentagon, and they know a lot more about it. And this was leaked. This online, so have a look at the UFOs if you haven't seen it, because it's a real thing. It's no longer a flying saucer. it's a real deal. So what I've got is a couple of rounds of copper around this, and we're just going to gently warm her up. Put plenty of solder on to give it some thermal mass there. And we're just going to heat this up. As I say, this is a better method than using a heat gun, because a heat gun just cooks everything unless you've got very precise control on it, and it's difficult to get it hot enough without overheating the board, the actual board itself, whereas this is a gentler method. It's a bit smoky. Right. So I think I've got enough on there now. So I get my tweezers. Slurp of tea. Yeah, so check out the UFO situation, because it's getting serious. They just don't know what these things are. And I quite like the Pentagon's agreed, look, these UFOs exist, and they don't have a reactive propulsion system, because there's no jet plume and no wings, and they can hover and then shoot off at high speed, showing amazing acceleration. And yeah, they don't know what they are. And then what I like is all these physicists saying, well, no, we're going to look at the Higgs boson and can give us another £100 billion to notch up the power on our Hadron Collider, just in case we might find a new force of nature. And the physicists have been absolutely silent. They haven't made a sound about what it could be, because they don't have a bloody clue. All the, you know, it appears to exist, and all the top physics people don't really know what it is. Nobody knows what it is, actually. But I find it quite entertaining, because, you know, these guys are going for grants all the time. More and more money, please. Public money. I want to build the bigger, better particle accelerator. You know what? Einstein didn't have a particle accelerator. I mean, they should say to these guys, look, perhaps, you know, could you concentrate on saving the planet for us? And meanwhile, we'll just wait for another Einstein to come along. I think that's a better plan, don't you? Wait for a new Einstein or Pauli or Bohr, somebody who's a bit cleverer than you lot. I'm sure you love going to all your lovely conferences all over the world, well, before COVID, and flying around burning up jet fuel, adding to the environmental problem, but you fancy yourself as being quite bright. Go and invent a clean source of power instead of worrying about smashing protons together at the speed of light, because, to be honest, Einstein would probably work it out from a thought experiment while you're still spending billions of public money fiddling whilst the world is overheating. And perhaps you ought to consider the moral duty that you have to use your super bright intelligence to save the planet. Would that be nice? You know, because none of you are going to win the Nobel Prize probably, or one or two, but, you know, it's pointless if there's nowhere to enjoy the Nobel Prize unless you're up to your knees in water and typhoons and storms and floods and stuff. So get on it. Stop dreaming. Start working. That's what I say to you physicists out there. Save the world, and then you can look for your new Higgs boson compatriot, or the anti-boson, or mesons, or quarks, or whatever it is you're looking for, or you want to math. Do that in your spare time. Save the planet, please, and use some public money for that instead of trying to out-accelerate the Americans. So that's how you take the chip off anyway. So I'm going to whop a new chip on there, and I'm confident it's going to work. Usually when this chip has gone, you turn it on, there's no power, but if you, it's a pain to take apart actually, because you have to take all these controls off, all these controls off this panel to get to the amplifier board. So it's a major strip down job, and then you just power it up. You'll feel this gets very hot, and it's the chip. And also these chips heat up and they cut out, or you can get distortion on one channel, minor distortion, They're not the most reliable of chips, put it that way, but they're okay. But you know, you wouldn't win any awards with designing a board one of these. I'm guessing that's why Philips have withdrawn them. Hopefully the newer ones are not so ambitious on power, but they deliver the RMS is what we need in levels that we need, and hopefully they're a bit better engineered. Otherwise NXP wouldn't have just obsoleted them. But they sold them all off to China at a bottom price, so all these types of things are turning up. 480 watt amplifier modules that utilize one of these, and quite for the price. Well, it says Rubicon on there, but they ain't Rubicon. They're fake. The printing's awful. A Rubicon capacitor I've ever seen has got a nice crisp lined up printing, but you've got a nice heatsink here and some inductors and two of the 8954 chips in there for about 15-20 quid, and a couple of bridge rectifiers. Yeah, or you could use it as an amplifier module if you don't want to rob it for the 8954s. But I'll do a thing on that later. Yeah, so that's that. Anyway, I just thought I'd give you a quick rundown of these. The power supply section is fiendish, very clever. Haven't seen one like it, but again, not that reliable, but is repairable. So if you've got one, you want to fix it, let me know. If not, I hope you enjoyed watching, and pop down there to the subscribe button and give it a bit of a push on the titty button for me, and oh yeah, leave me a like because I'm quite fond of likes too. So anyway, take care and see you soon.